Think about this for a second. Your heart beats over 100,000 times a day, and you don't even have to think about it. But have you ever stopped to wonder how? It's not magic. It's this incredible piece of biological engineering. Today we're going to take a journey deep inside that system to uncover the invisible electrical network that powers every single one of your heartbeats. Let's dive in.
So let's just start with the most fundamental question there is. How does your heart even know when to beat? I mean, it's a pump, sure, but what's the switch? What tells it to go second after second with such perfect, reliable timing?
Well, the answer is pretty amazing. Your heart has its very own hidden electrical network. It's a specialized web of cells called the cardiac conduction system that creates and sends out electrical signals, telling your heart muscle exactly when to squeeze. Our journey begins at the very top of this command chain.
Okay, so our journey starts right at the top, at the heart's command center. All right, let's meet the boss. It's called the sinoatrial node, or SA node for short. And what's just wild is its size. This thing is tiny. We're talking smaller than your fingernail, but it has the huge responsibility of kicking off every single heartbeat. It's just a little bundle of special cells tucked away in the heart's upper right chamber. So you might be wondering, how fast does this little boss actually work? Well, in a healthy person who's just resting, the SA node fires off an electrical impulse somewhere between 60 and 80 times every single minute. That rhythm, that steady pulse, is what you feel when you check your wrist. It sets the baseline tempo for your entire body.
You know, in physiology, they call the SA node the center of the first order. It's a fancy term, but it really just boils down to one simple rule. It leads because it's the fastest. It's just naturally quicker on the draw than any other part of the system, which makes it the undisputed leader of the heart's rhythm.
Okay, so the signal is on its way. But now, the journey takes a really interesting turn, involving a deliberate and kind of surprising delay. So from that SA node, this electrical wave just explodes across the heart's two upper chambers, the atria. It moves pretty fast, about 1 meter per second, and that's what causes the atria to contract and push blood down. Its next destination is a critical checkpoint in the network. And this is where it gets really, really cool. After zipping along at 1 meter per second, the signal hits this checkpoint, the AV node, and the speed just tanks. I mean, it drops all the way down to just 0.05 meters per second. That's a 20-fold slowdown. It's like you're flying down the freeway and then bam, you hit a total standstill. So that makes you wonder, right? In a system that's all about speed and getting things done, why on earth would the heart's own wiring create a massive traffic jam right in the middle of everything? Well, it turns out this isn't a bug, it's a feature, and a brilliant one at that. This tiny little pause, we're talking just 0.08 of a second, is absolutely crucial. It gives the upper chambers just enough time to finish squeezing all their blood down into the ventricles below. Without it, the whole pumping action would be chaotic. This little delay is the secret to a perfectly timed heartbeat. Okay, so once that crucial pause is over, it is full throttle time. We're hitting the superhighway. After it clears that AV node checkpoint, the signal jumps onto this express route. It shoots down a path called the bundle of His. It splits into right and left branches, and then it just fans out through this whole web of what are called Purkinje fibers. Bam! Just like that, the signal is delivered to the entire lower part of the heart.
And when I say superhighway, I am not kidding. The speed here just rockets up to 4, sometimes even 5 meters per second. That incredible speed is what makes sure that those huge ventricular muscles contract all at once, in one powerful, coordinated punch. That's the big squeeze that sends blood out to your lungs and the rest of your body.
So we've seen the main system, but what happens if the main power source goes down? Well, the heart has an answer for that too. It's got its own backup generators. So let's play what if for a second. What if the SA node, the big boss, suddenly gets sluggish or just stops working? Does the whole system shut down? No way. The heart has this brilliant backup plan built right in. And this chart shows you the chain of command. See, other parts of the system can actually set their own pace, but they're all progressively slower. If the SA node conks out, the AV junction can take over, but it's slower, around 40 to 60 beats a minute. And if that fails, well, the ventricles themselves are the last resort.
firing at a much slower 15 to 40 beats a minute.
And this right here is the key. A backup system only kicks in if the signal from the one above it doesn't show up on time. It's really simple. The faster pacemaker always wins. It's a straightforward, life-saving chain of command.
It's like our source material says. Even though there are all these potential pacemakers, under normal circumstances, there's only one, the sinoatrial node, which has the greatest automaticity. It's that natural speed, that faster rhythm we talked about, that automatically makes it the conductor of the whole orchestra.
So, there you have it. This incredibly complex, self-regulating, and amazingly resilient electrical system. It's a perfect dance of signals and delays, happening over and over again, something like 3 billion times in an average lifetime. Which kind of leaves you with one final, big question, doesn't it? What happens when this perfect dance misses a step? Well, that's a story for another time. Thanks for joining.